Yeah, simple case, right?
Exactly. Small example, simple case. It says n, you have n standard six-sided dice are all. The product of the numbers or can be any of 936 possible. So there are 936 possible values, right? So let's
Yeah.
check for n. We want to see, okay, if we have n1, the product
There's six.
has how many cases?
There's six, right?
Exactly.
Six.
What about n2? Check n2, how many different cases are there?
Okay. I got 18.
18. Okay, let's check. Here we have 1, 2, 3, 4, 5, 6. Let's copy them again. So, let's concept power of 5. Power of 5, we can have 5 squared or 5 to the 1 or 5 to the 0, right?
Yeah.
So for 5 squared, how many cases are there?
Five. Wait, what is 5
Let
squared?
the
5
product.
1.
The product is multiple of 25 or 5 or is not multiple of 5, right? 3 cases. Agree?
Right, okay.
Okay, suppose product is P, product P. So 5 squared is the maximum that divides when we write 2 divides this, it means it's maximum power. 5 squared is the maximum power that divides P or 5 to the 1 or 5 to the 0. It means that we don't have any 5. So in the first case, how many products are there that is multiple
1.
of 5 squared? Only 1, 25. What about this one?
Uh, 3. No, 4. 4. 5.
5. 5.
5.
Because we have
5.
1 5 and the rest can be one of these 5 cases, right?
Yeah.
Now let's concept 5 to the 0. So it means that there is no 5, right? So
Yeah.
we can erase these two 5s. So we have this. Okay. Now here let's focus on power of 2. In this case, case 3, 1. So what's the maximum power of 2 that can divide the
Uh, maximum is 2 to the power 4.
good job. Next case 2 cubed, right?
Yeah.
Next case 2 squared. Next case 2 divides b, and last case 2 to the 0 divides b, right?
Yeah.
Okay, so we should check all these cases. 3 to the 4, 3 to the 5, 3, 5. Okay, what about case 1? How many cases do we have?
1.
1. What about this case?
1. No, 2.
What are the two cases?
There's 2 cases.
Yes. Can you tell me those two cases are what?
8 and 24.
8 and 24. Good job. Two cases. What about 2 squared?
4, 12, and 4, 12, 20, and 36.
Okay, let me tell you a better way, a good way for calculating these things. I want to concept power of 3. Okay? Power of 3 can be what numbers? Because do you agree here we have only 2 and 3 in our product?
Yeah.
Okay, so power of 3 can be what numbers?
What do you mean power of 3 can be what numbers?
Look,
Like how
for
many?
example, power of 3 can be 3 to the 0. Means 4 times 3 to the 0 is 4. 4 times 1, we can create 4, right?
Yeah.
We can also create 3 to the 1. 4 times 3, right?
Yeah.
Can we create 3 squared?
Yeah.
How?
6 times 6.
Exactly, but we cannot create 3 cubed, right?
Yeah.
Okay, so here there are 3 cases, right?
Right, okay.
What about next one? For this one, calculate how many ways are there.
It can also be 3 to the power of 0, 3 to the power of 1, and 3 to the power of 2.
Exactly, 3 to the 0 is 2 you can create. 3 to the 1, 6 you can create. 3 squared, 18 you can easily create. 6, 3 cases, right?
Yeah.
For this one also, again, 1 and 3 and 9, you can easily create them, right?
Yeah.
So it would be what the answer for N2?
12.
That's 12 and 5 and 1, 18, right? And good job, your
8.
answer is 8. Your solution was different, right?
Yeah.
You used what?
No, I just counted.
You wrote down all numbers that can be created, right?
Yeah.
Okay, so we want to use this way to find a pattern to find for general n. At the end, we want to find for general n how many possible cases are. So try n3, okay?
I think I have an answer, but I think it's wrong.
You've reached what?
Because I think the answer is supposed to be 54, but I got 53.
Okay, let's check. Again, let's consider power of 5. Power of 5 can be what to what?
3, 2, 1, and 0.
So for 5 cubed, how many cases do we have?
For 5 cubed, that's one case.
For 5 squared, how many cases?
5.
For 5 to the 1, how many cases are there?
25.
How many?
25.
No. This part is wrong. Calculate this one again.
There's a 12.
Exactly, because when we have 5 to the 1, it is similar to this. 9 plus 2, 11 plus 1, 12, right? 1, 5, 12, right?
What?
Okay, now for 5 to the 0, we have 3 of this, right?
Yeah.
Okay. So split to different cases like this and calculate this one.
Yeah. I've done that.
It is what?
Well,
You've split it, you've used casework for solving this?
yeah, like if it's 2 to the power of 6, or 2 to the power of 5, 2 to the power of 4, 2 to the power of 3.
Okay, good job. So let me check. We have 2 to the 6, 2 to the 5, 2 to the 4, 2 cubed, 2 squared, 2 to the 1, 2 to the 0. For this one, how many cases are there?
1.
What about next one?
2.
We can have 3 to the 0, 3 to the 1. We can say 4, 4, 6, right?
Yeah.
What about this one?
3.
3 squared. We can change 4 to 6. 4, then we have 3 cases. What about 2 cubed?
4.
This one.
4.
Yes, all of them will be 4.
Yeah.
So 1, 2, 3, 4, 16
20.
plus 3, 19, 21, 22, right?
Yeah.
22, 34, 37, 38, right?
Yeah.
Let me check it again. 18, oh no.
No, 40.
40, yes. So now we want to calculate it for general n. If you can calculate for general n, if not, take n4 and then general n, okay? Try.
Is that supposed to be like a pattern here? Like the
More than pattern, pay attention to this. Look, for example, again for next one we have 1, 5, 12, 22, and you need to only calculate one more case. And then you should split to these cases. For n also you can use same approach, okay?
Okay.
And you can find a recursive sequence, okay?
Okay.
Okay, try.
I think I have a recursive formula, but I don't know how to like I can't calculate.
Oh, you don't know how to find closed form, right?
Yeah.
Can you tell me your recursive formula is what?
An equals an minus 1 plus n plus 1 times n plus 2 divided by 2 plus n times n plus 1.
Plus what?
N plus 1 times n plus 1. No, times n plus 1.
This one times n plus 1, like this?
No. N minus 1 plus that plus n times n plus 1.
This one, right? Okay, let's check. A3 is A2 by the formula you said 4 times 5 over 2 plus 3 times 4. Which is A2 plus 20, 10 plus 12, 22. 22, that's correct. And if you check A2, it's A1 plus 3 times 4 over 2 plus 2 times 3. So it is A1 plus 6 plus 6, 12. Good job. I think this formula is correct. Let's check it together. As you can see, for an, we can say it is equal to an minus 1 if power of 5 is n or n minus 1 to 1, right?
Yeah.
Now if power of 5 is 0, then we know that we have 1, 2, 3, 4, 6, right? For n times. Agreed?
Yeah.
This one all the way. So then for this one, we concept power of 2. Power of 2 can be 2n. Can be 2n minus 1. So this one is 1, this one is 2. All the way to, first let's consider 2 to the, if we change all of them to 6. 2 to the n plus 1 we have, and 2 to the n. If we have 2 to the n, power of 3 can be from 0 to n, so n plus 1. And this one is n, right?
Yeah.
2 to the n plus 1, okay. So 2 to the n minus 1, n plus 1 to 2 to the 0, n plus 1. Then you considered 1 to n plus 1. You said n plus 1 times n plus 2 over 2. And from here to here, 0 to n minus 1 is n. n times n plus 1, right?
Yeah.
Okay, good job. But you can't find closed form, right?
No.
Okay, let's try to get it. Well, you can solve it by telescoping sum.
Yeah, but I know that, but like I don't know how to calculate.
Okay, so let me show you. Look here, because we have these, I want to write it as something, choose something. Can you tell me an minus 1? Instead of this, we can write what, choose what?
Um. N minus 2 choose n.
This one,
No, n plus 2. Sorry, n plus 2 choose n. Sorry.
n plus 2 choose n or 2, right?
Yes, same.
Plus, what about this one? How can we relate this one to something? Choose?
Um. 2 times n plus 1 choose 2.
Exactly. And do you agree we know an minus 1 is equal to n plus 2 choose 2 plus 2 times n plus 1 choose 2, right?
Yeah.
If we write an minus 1 minus n and an minus 2, it would be what?
M plus 1 choose 2 plus 2 times n choose 2.
All the way to a2 minus a1 is what?
A2 is A1 is 4 choose 2 plus 2 times 3 choose 2.
And if you add, you can cancel these. A1 is what?
A1 is 6.
Yes, the first column is what? You add all of them.
This is kind of the part I don't know.
Do you know hockey-stick identity?
Whose identity?
Hockey-stick identity.
Hockey stick. I heard of it.
Yes, let me write down. It's so much important. This one is R choose R plus R plus 1 choose R plus R plus 2 choose R all the way to N choose R. Remember it was what?
It was like plus R.
1 choose R plus 1, okay? Now if you use this, first column here is what?
It will be plus 3 choose 3 minus 4.
N plus 3 choose 3, good job. Minus 3 choose 2, minus 2 choose 2, minus 4. Exactly. What about second column?
Uh, 2 times plus 2 choose 3 minus 2.
It's 2 times n plus 2 choose 3 minus, oh yes, minus 1 here, or if you expand minus 2, right?
Yeah.
Okay, good job. Now check this formula that we've reached, if it is correct. Then you can find for which n, an is 936, right?
Oh, right. Yeah, okay.
Okay, try find correct choice.
I think it's E.
It's E.
Well, yeah, because I tried D and it was too small.
Okay. So let's check. An is equal to n plus 3 choose 3 plus 2 times n plus 2 choose 3 minus 4 minus 2 minus 6 minus
It cancels
6.
out.
It is this, exactly. But we should check
Yeah.
at least for one case, for example, 8, 3 to make sure it's correct. 6 choose 3
Okay.
plus 2 times 5 choose 3, which is 20 plus 20, 40. It's correct, right?
Yep.
Okay, now we can calculate A11. It's 14 choose 3 plus 2 times 13 choose 3, right?
Yeah.
So it's 14, 13, 12 over 6 plus 13, 12, 11 over 3. You can cancel, it's 4. You can cancel, it's 2. So 13, you can factor from 13. It is 2 times 14, 28. And 4 times 11, 44. 4 plus 8, 12. We have 1. 4 plus 2, 6 plus 1, 7. Look here, you can check. 3 times 2 is 6. If it was not 6, we don't need to calculate it, right?
Yeah. Yeah.
Okay, 13 times 72, 3 to 6, 21, 72. So it's 639. Good job, 936. So look, how could we solve this? By using a small example, right?
Yeah.
Okay, and it is a hard problem. I can say the difficulty is similar to hardest problem in BMO, BMO 1, okay?
Okay.